Example is what? PCl5. Now, what is the definition you can give? A definition can be given very simple. One s orbital and how many p orbitals beta?
3, sir.
3 p orbital and 1 d orbital. They mix, they merge together, they intermix with each other. All you can use words, intermix, merge, like that. To give how many hybrid orbitals we get here? 5. This type 5 we get, isn't it? So 5 we are getting like this, isn't it? 5 we are getting. 1, 2, 3, 4, and what happened? 5 hybrid orbitals we got. Now all these will arrange in which manner? Trigonal bipyramidal manner actually. Like this they will arrange. They mix, what happened? They arrange like this. I show that one in example with PCl5, phosphorus pentachloride here. Okay. Now first of all we see the ground state configuration will be 3s2 3p3, right? The ground state configuration will be what? 3s2 3p3. Now 3p3 means half fill configuration. You may have one d orbital also there which is empty, 3d orbital which is empty. Now what happens beta? This electron will shift into what here? To make unpaired electron, isn't it? It will shift into like this. In this way it will shift here. Now all these are intermixing like this. Everything is mixing. One s orbital, 3 p orbital and 1 d orbital is mixing. Now when they mix, what happens? We get 5 hybrid orbital. They looks like this. All these when mixed, what happened? They looks 5 sp3d hybrid orbitals we are going to get. Okay. Now they looks like this. I am showing this one like this. Here, 1 s orbital, 3 p orbitals are mixing, and 1 dz orbital is mixing. So you are going to get like this. We are going to get like this. See, trigon. This is what trigonal pyramid. This is trigonal actually. This part is what? Trigonal part. This is what trigonal. Now this will be bipyramidal. One pyramidal, first pyramid, and next pyramid. So this is called trigonal bipyramidal. This is your good. After this, what is happening here, isn't it? This is the trigonal bipyramidal structure. After this, what happened? 5 chlorines are there no, in PCl5. 5 chlorines are there no, they are overlapping like this. Now this I will show in diagram. I will draw a diagram here. I will draw it right. So it looks like this. 1, right? 2, 3, 4. So just I will do one thing here. I will make some correction here. We'll take what happened like this. Right. This is called what? Trigonal bipyramidal. Now how many chlorines are there beta? PCl5. 5 chlorines are there. So one of the pz orbital of the chlorine will overlap like this. 5 chlorines will overlap like this. Now in examination, no need to draw the diagram beta like this. No need to draw a diagram like this. This is actually what? Which hybrid orbital? sp3d. sp3d. This is the pz orbital of what? Chlorine. pz of what? Of chlorine. This is for phosphorus actually. sp3d. This is the pz of chlorine. And this is also what? pz of chlorine. This one also pz orbital of chlorine. This is also what? pz orbital of chlorine. Now here we are getting sigma bond, sigma bond, sigma bond, sigma bond, sigma. So I am drawing like this: phosphorus, chlorine, 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 chlorine. Now how many total sigma bonds? 5 sigma bonds. And what is overlapping here? This is what? sp3d, and this one is the p orbital. So sp3d, p overlapping is taking place. sp3d, p overlapping is taking How many? 5. Here, 1, 2, 3, 4, 5. This is called what? PCl 5. Okay. So we'll move toward the last structure like this. Here, 5 sp3 hybrid orbitals of phosphorus overlapping with what? PZ orbital. 3 PZ orbital of how many here? 5. 5 phosphorus chlorine bonds with trigonal bipyramidal structure you are going to. There are 5 PZ orbitals are there of chlorine which are forming overlapping with what? sp3d hybrid orbital. And when you observe the bond angle, here we get two types of bond angles. One is 120 degrees, other is what? 90 degrees. Let me see this one. Bond angle also I will explain. Here, if you observe what happened, the structure, again, coming to the structure here, if you observe the structure here, observe what happened, again, now if you observe what is the bond angle here in this case, 90 degrees. Now, if you observe what happened, bond angle in these two cases, 120 degrees, other you can take here or here, whatever it may be, 120 degrees it will be. Now, if I take in this way, this will have what? 180 degrees actually, isn't it? This will be 180 degrees like this. It will be 180 degrees. Generally 180 degrees, nobody consider that one, 90 and 120 degrees. But when you observe sp3, bond angle is 109 degrees. sp2, bond angle is 120 degrees. sp bond angle is 180 degrees. But sp3d is having 3 bond angles are there. 180, 120, 90. 3 bond angles are there. Isn't it? So 3 types of bond angles you are going to get. This is also important for you. Right? Next. Now, if you observe what happened, equatorial and axial bonds. What are equatorial bonds and what are axial bonds in this case? Now, here, if you observe what happened, what is equatorial bond? I'll write what happened, something drawing like this. Just a minute. Draw here what happened. Now, here, if you observe what happened, this one, and this one, these are equatorial. These are equatorial. Okay, this one also equatorial. This one also what? Equatorial. Now this one will be axial. This one will be the axial, and this one also will be axial. Okay, this part is what? Axial bond. This part is also what? Axial bond. This is what? Equatorial bond, equatorial bond, equatorial bond. Right? Now what they are saying, axial bond having got, which one is longer beta? Axial or equatorial? Which bond is lengthy? Axial bond length is what more? For axial bond length is more, so you can break easily. Axial bond length is generally what happened? Bond length is inversely proportional to bond energy. Correct or not? So more bond length, less bond energy. So easily we can cleave what? This bond. This bond. For example, I want to cleave like this. I want to, if I heat PCl5, this is very important beta. I will get what? PCl3 plus chlorine. Right? Now, which bonds are cleaved here? This one and this one is cleaved here. Axial bonds are cleaved here. Equatorial bonds will be remain like that only. These bonds will be remain. These bonds are there? No. They remain in the bonds compulsory. So, which one is weaker bond beta? Axial bonds are weaker. This one and this one are weaker here. Understood? So, axial bonds have been formed to be slightly longer. They are slightly longer. Hence, they slightly weaker. Then what actually compare with what? Equatorial. So, PCl5 is more reactive when you compare with PCl3. So, it will react to convert into PCl3 and it will be stable. Now, why it is unstable beta? Because of having what? Axial bonds. Because of having what? Axial bonds, they cleave very easily to convert into what? PCl3. Understood what? This point?
Yes, sir.
Which d orbital is involving beta and sp3d? Which orbital I have taken? Anybody? Which d orbital is involved? In sp3. I have taken one d orbital. Which d orbital I have taken? dz square I have taken.
DZ square.
dz square only I have taken because dz square can form axial bond because dz square looks like this, no? This looks like this, no? You have seen in the atomic structure it is. How many equatorial p cell bonds are there in the p cell 5 beta? How many equatorial bonds are there?
3.
3 are there.
3.
Right.
3.
Now, can you explain this one? Can you give answer? Axial and equatorial angles in PCl5 molecules are respectively. What is the bond angle? Axial. What is the bond angle in equatorial? Is it possible?
Sir, axial is 90.
120 and
Sir,
120.
equatorial is 90 and axial is 120.
Now you observe what I will draw a diagram better here. These are equatorial bonds, right? These are the equatorial bonds. And this one will be what here? Axial bonds. Now, equatorial means these two. Bond angle will be 120 degrees. Correct? Now this will be what here? Axial. Is it? So here we can take bond angle here only like this. So what will be it is 90 degrees. It is. Right? So equatorial, how much? This is equatorial, no? Equatorial. Bonding angle is what? 120 degrees. Axial, but we can't take axial directly. What happened? Directly you can't go for like this because one bond is there here. If you go for, we get 180 degrees, but 180 degrees is not there no here. In option, if they give 180 degrees, you can go. But option what they give 90 is there, so go for 90 like this. Correct? Understood here? I will move to what sp3b2 hybridization. sp3b2 hybridization. Here one s orbital, 3 p orbital, 2 d orbitals are mixing to give 6 sp3d2 orbitals. 6 sp3d2 hybrid orbitals. Right? Examples we see here. S of 6. Example you are taken. Central atom is what? Now sulfur here. Now we will take what? Sulfur configuration. Sulfur configuration is 3s2 3p4. So write down 3s2 3p4 for what? Sulfur configuration, and 3d orbital is empty. Now here we need 2d orbitals, no? But only one thing we'll do, we'll shift this one over here and this one over here. Like this we shift. So here we get one unpaired electron and here we get unpaired electron from here like this. Now what we get? Something. First if we excite this electron, we get this one. Again if we excite here also, what happen? Getting like this. Finally we are getting what? This one. We are getting final. Now how many? 1 s orbital, 3 p orbitals and 2 d orbitals are intermixing to give what? sp3b2 hybrid orbitals. Example I have taken what? S of 6 here. Now this looks what happened. It looks how? sp3d2. It looks like this. 6 hybrid orbitals we are getting. No? 1, 2, 3, 4, 5. This way, sp3d2 can be shown like this. It is called octahedral structure. Octahedral structure. Correct? sp3d2 will have this type of structure, octahedral. Otherwise, square planar bipyramidal also we can call. Square planar bipyramidal. Square planar bipyramidal structure, isn't it? So sp3d2 shape is what? Octahedral or square planar bipyramidal. Why? Because it got 6 hybrid orbitals. When you have 6 hybrid orbitals, it will looks like octahedral. Move to what? Example S of 6. Now the bond angle we are going to see here 90 degrees. I will show that one. And important thing is this one. Now which d orbital is used in the sp3d? dz square. Now in sp3d2, dz square and dx square y square we can take. Dx square and y square we can take. So why only these two we can? Why not be different? dxy, dyz? Because these orbitals will along the axis. X square and y square, they will be presented along the axis they will have. Wherein dxy, they present between, isn't it, x and y. So between orbitals we don't require actually. Whichever along the axis only we can take. Understood here? sp3d2 hybridization, which orbitals are involved? X square, y square and dz square orbitals are involving. And here bond angle is what? 90 degrees. Now this is the structure of what? Octahedral structure. See, these are out in plane, square planar like this is square planar. Correct or not? Square planar. And we get a pyramid structure here. And we get a pyramid structure. Now this is called what here? octahedral structure. So square planar bipyramidal or octahedral structure, isn't it? When you were drawing with pen, what happened? How to draw with pen? Yes, lowering, lowering. Here what happened? Lowering, 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 lowering. Now here anywhere if you take bond angle, anywhere you take bond angle, that will be what? 90 degrees. If you take from here to here, what happened? It will be 180 degrees. That is nobody asked that one. Generally they will ask this one 90 degrees. Right? Now this is what actually square planar pyramidal structure. Bipyramidal structure. Like this it is. Very simple it is. Important points. Shape is octahedral. How many sigma bonds you got, beta? How many sigma bonds you see? Lowering, lowering,
See.
sigma bonds. And what type of overlapping is taking place? This is sp3d2. This is what again? pz orbital or p orbital. Simply pz or p orbital. So which type of bonds are getting? 6 sigma sp3d2 p. sp3d2 p overlapping is. And you got any pi bonds over here? No. Until now we didn't got any pi bonds here. 0 pi bonds we got. Now can you explain which is correct one? Order of bond angle? Which one is correct option, beta? Order of bond angle? Are you there?
Sir, C.
C is the correct answer. How it
Sir.
is? sp3 how much, beta? 109 degrees. sp2 how much, beta? 120 degrees. sp how much, beta? 180 degrees. Yesterday only we discussed this one. Next. It's already you know this one, 120 just now. Now, can you say the answer for this one? Is it possible? Which orbital is used for oxygen atom to form sigma bond with like this in O double? Actually, it is not explained yet. No problem. Next day we will discuss this one. Which sigma bond used here? Anybody? Pure p orbital. Now here there is no hybridization is involving in this case. It's purely what overlapping only. It is purely what happened? Overlapping only. It will explain in the MOT theory. Now, two hybrid orbitals are having 120 as a bond angle. Correct? Now tell me what is the percentage of S character in that one?
30.
When we get what happened?
33.3.
120 degrees beta? In sp2 hybridization only we get 120 degrees. So in this case, percentage of S will be definitely 33.3. Like this also they may ask some questions. Here this hybridization, how to identify the hybridization, I will explain. Okay, I will explain based on next in today only. We'll see some exercise on this one. Okay, that one no problem. Here also you will get all these things. I will discuss this one. Okay, day 2 bond is not at all discussed here. I will explain some more things here. How to identify the hybridization and also what that formation of C2 and H2. Take one slide here and I will explain what formation of C2 we'll see the formation of C2H4. Formation of how C2H4 is formed. Formation of C2H4. Formation of C2H4. generally, two carbons are there. You write down like this. Two carbons. You have to write like this. Two carbons are there. Write down like this. And here, four hydrogens are there. No. For each carbon, put two hydrogens. For each carbon, put two hydrogens. Otherwise, you can put like this also. The two hydrogens you can put like this also. One hydrogen here. Other is here. One hydrogen is here. And other is here. Now, a carbon can have how many bonds beta maximum? How many bonds will be there on carbon?
4.
Four only. So we don't have the hydrogens. So remaining two bonds we have to keep. So one is sigma bond, other is called pi bond. Sigma bond, pi bond. This will be sigma. Above the sigma bond always called what? Pi bond. Right? Now this is called simply CH2 double bond CH2. Now I am explaining how it will form now. How it will get actually. Now remember, when you have one pi bond beta, whenever if you have one pi bond, the hybridization will be sp2. If a carbon is having one pi bond, it will be sp2. If a carbon is having two pi bonds, it will be what hybridization? sp3 hybridization. If carbon is having zero pi bonds, no pi bonds, only sigma bonds are there. So this one is sp hybridization. So this will be what? sp3. So this will be sp hybridization. Which one? When you have one pi bond, sp2, two pi bonds, sp, zero pi bonds, sp3 hybridization. This is very important for you. Now tell me, what is the hybridization of C2H4 based on this concept? What is the hybridization of C2H4?
Sir, sp2.
Ethene or ethylene? Ethene or ethylene? Ethylene is a common name, isn't it? Whereas ethene is iupactane. So definitely one pi bond is there, sp2 hybridization. So now I have to explain this structure here. Now carbon configuration will be helium 2s2 2p2 configuration. Now I am writing 2s2 like this. Like this. This is the ground state beta. This is the ground state. Now what I am doing, I am exciting this electron over here. First excited state. First excited state. So here one electron. Here it is what? 3 electrons we get. Now even though you are having all orbitals are having electron, now only one s orbital and two p orbitals will overlap here. One s orbital plus two p orbital. This is not involving beta. This is again pure only. It is pure atomic orbital. Understood here? In ethene, one s orbital, two p orbitals will intermix to give what? sp2 hybrid orbitals. sp2 hybrid orbitals were going. Along with one pure atomic orbital. So sp2 shape is what? Like this, no? The shape of sp2 is like this, correct or not? So I am drawing that one. You see, sp2 I am drawing like this. 1, 2, 3, like this. This is sp2. But how many carbons are there, beta? How many carbons I have taken?
2, sir.
Right? 2 carbons I have taken. 1, isn't it? Like this. Next one will be 2, like this. First carbon, second carbon. Now, hydrogen is overlapping on sp2 hybrid orbital. So, how many hydrogens are there? 2 hydrogens are there. Take one hydrogen here. One more hydrogen is here. And here for this one also what happened? One more hydrogen is here. One more hydrogen is here. Right? Now, so here each atomic orbital is having a single electron. So here it is having a single electron, single electron, single electron. Here also what happened? Single electron like this. Similarly, hydrogen will also have what configuration? 1s1 configuration, having one single electron. Now put here that electron over here. And here also what happened? Like this. And here also something. And here also. Now this is having a pure atomic orbital. Pure atomic orbital. Now put that pure atomic orbital over here. Like this is a pure atomic orbital. And here also put the pure atomic orbital over here. So this is what pure atomic orbital. And same thing, pure atomic orbital. Now here, you're also having one electron. See, this is you're having an electron here. You put that electron here, the put electron here. Now what happens here? These two will overlap and these two will overlap. When they overlap, how they look? Let me see this. Now, you see here hydrogens overlap. Hydrogens are overlap. Now this is here sigma bond is forming. Now here what happened? Sideways overlapping. Sideways overlapping. Pi bond is formed. You can show overlaps on above and below beta. It will overlap above and below. But only how many bonds are to take here? Only one pi bond only. Completely it is a pi bond only. Because it is taking place with only one orbital only. Okay, this we are representing like this. Carbon, single bond, hydrogen, 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 hydrogen. Now this is a sigma bond beta. Sigma bond I am representing this one. This is a sigma bond. Now this overlapping, no, something like this. Overlapping something like this. This I am showing as what? This is overlapping, is sideways overlapping, isn't it? Sideways overlapping. All are having some electrons like this. Simply you can call right like this also. You're drawing like this. So this is a structure of what? C2H4, formation of C2H4. Now questions, what type of questions you will get here? One is what diagram. This diagram you have to remember. This diagram is this one is easy for you. Okay. Now question is how many sigma bonds are there beta in C2H4? Number of sigma bonds are how many? Do fast. How many sigma bonds are there?
5.
Very good.
5, sir.
One, right? 1, 2, 3, 4, 5. Now there are 5 sigma bonds are there, right? There are what? 5 sigma bonds are there. Now how they are formed? Let me see this one also. What are they also? Let me see. And there are 4 sigma bonds which are overlapping with sp2 and s. This is from hydrogen. This is from carbon. Correct? 4 like this one. 1, 2, 3, 4. One sigma bond is there that is overlapping because of sp2 and sp2 like this. See this one. sp2, this one better. Are you observing this one? This one. sp2, sp2. And there one pi bond is there. One pi bond is there that is overlapping between what? pz orbital and what happened? pz orbital. This one. This part. This part is overlapping here like this. This is a pz orbital. This is not sp2 beta. This is not sp2. This is a pure p orbital. It is. It's a pure p orbital. It is. Okay. So this is the things we are going to get. Total 6 bonds. Out of them 5 is sigma, 1 is pi bond. Now what is the bond angle? Anybody? What is the bond angle? What will be the bond angle? Which hybridization beta it is? Which hybridization it is?
So 120 degrees.
sp2. So definitely here you are going to get 120 degrees. Okay, the bond angle, you observe what happened. Here bond angle will be what here? 120 degrees only. This is the thing. Bond angle also we have to remember. Bond angle will be 120 degrees. This is the important terms you have to remember. Right? Now we'll move to what? Next hybridization, sp hybridization. I will move to what? sp hybridization. Sorry, sp hybridization. I'm moving here. sp. Example, I can take C2H2 beta. It is C2H2. That one is C2H4. It is C2H2. It is called what? Ethine. Ethine are called acetylene. Acetylene. Why? Because when you have one pi bond, ethene, when you have two pi bonds, ethine. Ine because of two pi bonds it is. It looks like this. C double triple bond CH like this. This is a structure. There are two pi bonds are there. Now, what type of hybridization? Two pi bonds means what type of hybridization we get? Two pi bonds are there. Pi bond, two pi bonds are there. SP hybridization. This is SP and this one also what? SP hybridization. Understood here? Let me see what happened. Next, how it is forming. Again, carbon I am taking here. So configuration again, helium configuration. 2s2, 2p2. 2s2 we can write like this. 2 electrons. 2p2 we can write like this. Again, this is exciting here. Ground state. In excited state, what happened? You are going to get like this. Now, in this case, only one s orbital and one p orbital will mix here. These are mixing here to give sp hybridization. And these two will be what here? Pure atomic orbital. Pure p atomic orbitals. In the previous case, we got one pure p orbital. Here we get two pure p orbitals. Here. There are how many here? Two pure p orbitals. sp definitely will be in linear shape. It looks like this here. sp hybrid orbital. This is the sp hybrid orbital of first carbon. Plus what happened? sp hybrid orbital of second carbon. Now it is having two pure p orbitals. No, write down that one like this. One pure p orbital, second pure p orbital. Again, one pure p orbital, and again second pure p orbital. Now this one will be the sp hybridization, sp hybridization, sp. It is also what? sp. This one will be pure p orbital. This one be also what? Pure p orbital. Pure p atomic orbital. This one will be pure atomic p orbital. This one also what? Pure atomic p orbital. Now next, I told you no, each carbon is overlapping with hydrogen like this. Hybridization like this. Hydrogen, S from orbital from hydrogen. Is also what happened? S from orbital, S orbital from hydrogen. Okay. Now what happens here? These two will overlapping now, and this will overlapping, and this one also will overlapping. In that case, we are going to get like this. Here we get hydrogen. Here we get hydrogen. Now I'm drawing what? Pure atomic orbitals. Pure atomic orbitals. I'm drawing pure atomic orbitals. Like now we got here a sigma bond is formed here. We got a sigma bond here, isn't it? Now these two overlap here. These two will overlap here. For example, if it is what, just imagine it is a pz orbital. This is the pz orbital. Now pz overlapping taking place like this. Pz overlapping. Next, what happened? This will be py orbital. Py is overlapping like this. This is py, and this one also what? Py. Similarly, what happened here also? Overlapping is taking place. Now this we can represent like this here. C. Okay, sigma bond, this one, sigma bond with carbon. And each carbon is bonding with two hydrogens, one hydrogen like this. Now we got a pi bond over here. One pi bond between what happened? PZ and PZ like this. One pi bond like this, right? Second pi bond. This one. So we got two pi bonds out here. Now thing is that bond angle will be 180 degrees. And how many sigma bonds are there, beta apple? Number of sigma bonds are how many? One sigma bond or three sigma bonds?
One.
Total number of sigma bonds are
3, sir.
3 are there.
One.
It is
Three.
it is also sigma bond. This is
The
formed
total.
between sp and s orbital. This is found between sp and s orbital. Now you can see there are two sigma bonds with sp and s overlapping. This is from carbon. This is from what? Next, one sigma bond between sp and sp, between two carbons, this one and this one, sp and sp. And two pi bonds are there. Okay, two pi bonds with p orbital and p orbital. Two pi bonds with p and p orbital. It may be what? pz or py like that. So you got how many total? Two, 5 bonds. 5 bonds. This is about the formation of ethylene structure. So you may get questions again, how many sigma bonds, what is the hybridization? This may be better. This is the formation of C2H2. So with this, what happened? Hybridization concept is. Now we'll move to what our NCERT textbook now. We'll move to now NCERT textbook now. What type of questions we have to practice? Everything is completed better. This is actually C2H2. Your textbook, you open this one. Here it is C2H4 is given, no? Formation of C2H4 is given here. So here this is forming like this. This one you got finally what happened? This diagram and this diagram. Next, what happened for C2H2? This one, C2H2. Okay. Now what we can take here? Like this. Formation of sigma and pi bonds like this. So this already we completed here. Right. Now don't bother about these structures. It will get in 12th class. Don't bother about this one. You just take only these things. I will explain now how to identify the hybridization also. First of all, we see some questions here. What type of questions are there in the NCERT textbook? Only one topic is left, that is molecular orbital theory. Main topic is there that we'll discuss tomorrow. I'll start molecular orbital theory and hydrogen bonding also there, that also we'll discuss. Hydrogen bonding. 2 topics will be there. Tomorrow and day after tomorrow, we're going to complete this chapter, chemical bonding. 2 topics are left. Important is molecular orbital theory and hydrogen bonding. So 2 topics are there. We'll discuss tomorrow, but we'll see what type of questions we have to discuss. Now, if you observe what happened, 4.24, 4.23 up to 4.23 we have done actually. Correct or not? What is mean by hybridization of atomic orbital? Definition. I think everyone knows the definition of hybridization. Describe the shape of sp, sp2, sp3 hybrid orbital. Shape आप कैसे लिखते हैं बेटा? sp, ये sp है, हो गया. sp2 कैसे लिखते हैं आप? Isn't it? हो गया sp2. sp3 कैसे लिखते हैं? Like this. So completed. sp, sp2, sp. Finished. 2 marks question is finished now, isn't it? Definition of hybridization, I think everyone knows this one. Now here what happens, it is nothing but coordination compound bond. I will explain this one. These 2 things I will explain here. 4.25. All of you please note down better, because see, I will not record. I mean, I'm recording this one. If you see the record, you will get. But otherwise, what happened? I'm not post anything here written. So you just take this one. Aluminum Cl3. How they're asking the change in the hybridization of aluminum in this case. What is the hybridization here and what is the hybridization here? How to identify this one? I will explain some beautiful example here. Please, all of you, listen carefully, because it's very, very important. You can do n number of examples if you know this shortcut. I'm explaining this short better. This shortcut you don't get in anywhere. In any textbook, they don't give this type of shortcut. All of you listen carefully. First of all, you select the central atom. Aluminum is a central atom. Correct or not, better? In this case, what is central atom? Aluminum, yes. Right? Now, anybody say what is the aluminum group number? The group number of aluminum possible for you?
3.
It is a 13th group, right? But I will take a 3rd year. 3rd year, 13th, both are what? Same only. Both are what? Same only. Okay, but I am taking 3rd year. Why? Because it is required for me. 3rd year Valency shell will be ns2 np1. Correct or not? ns2 np1. 2 plus 1 equal to 3. Therefore, third year group. Correct? Now, how many electrons I can take in aluminum? Valency shell electrons are how many beta? In aluminum? In aluminum, how many valence electrons are there beta?
3.
3.
3, right? Now, how many surrounding atoms are there here?
3.
Now, each surrounding atom is taking one electron like this. Correct or not? Is it correct or not? Understood or not?
Yes.
Yes.
Now, each bonding you take as a hybridation. Okay? Yes, P1, P2. Okay? Yes, S2 we do S, P1, P2. After that, P3. P3 after that, what we have to go? D1, D2 like that. Now, hybridation will be what here? sp2. So, you can write here AlCl3 is having which type of hybridization beta amper? This is having sp2 hybridization. Very simple or not? Easily, anything you can identify like this one. Any molecule. Now we go for AlCl4 minus. Now AlCl4 minus they said. Minus means extra one electron we have to take. Correct or not, beta? Al4 minus they are saying it. Minus. Extra I have taken one electron here. Correct or not? Understood? AlCl4 minus means one extra electron I have to take. Now, how many chlorine atoms are there here? 4 chlorine atoms.
4.
Now, each one is form one bond. Now, again take S, P1, P2, P3. Now, the hybridization for this one will be sp. The change in the hybridization here, sp2 to sp3. You take in your textbook or in your notebook this one. All of you, please write down. Otherwise, if you are unable to write now, just take snapshot now. Take snapshot for this one. This one is important for you. Now let me take the same concept we will apply for 4.26. Now we will apply. Change in the hybridization of boron and nitrogen atoms as a result of the following reaction. Is there any change is taking place? Let me see this one. For boron and nitrogen atom. So here the space is very less is there. So I will take on PPT. I will explain this one. Okay, beta. We'll take what a PPT this one. 4.26. I will explain on PPT. All of you please listen. 4.26. Now here. First one is what? BF3. When it is reacting with NH3 to give what? NH3, I am writing like this. A dative bond is forming BF. This is forming action. So this one is forming like this. This is a dative bond. Dative bond is what happened. Nitrogen is donating lone pair and boron and nitrogen sharing equally. One will donate and both will share equally. So let me take first of all boron hybridization. Boron central atom beta. Boron is a central atom. So what is the group number of boron beta? Which group it is? Boron.
Third.
Again, third year. So we have to take how many electrons beta? 3 electrons. And each, how many fluorines are there? 3 fluorines are there. Take here also what? 3 fluorines. Now hybridization will be here again same. Yes, P1, P2. So hybridization will be sp2. So for boron, hybridization will be sp2. Now what about nitrogen? Which group beta nitrogen? 50 or 15th group. Okay, 50 or 15th group. So I have to take how many electrons here? 5 electrons are there. I will take 5 electrons. Now, 3 hydrogens are there. Take what happened? 3 hydrogens like this. But one lone pair is there. This is called lone pair beta. This is called what? Lone pair. Now, one bonding electron will have how many electrons beta? Bonding will have how many electrons?
2.
2 only, no?
2 electrons.
So 2 electrons.
2.
Correct or not? Here also 2 electrons. And bond also carries what happened? 2 electrons. That means it is also taken as a bond pair only. It is also what? Electron pair. So 3 here what happened? Electron pair. It is also electron pair. Electron pair means it may be lone pair or it may be bond pair. Understood now everyone? It may be lone pair or it may be bond pair. Now, each electron pair you can take as a hybridization. Electron pair, hybridization, S. Electron pair, hybridization, P1. Electron pair, hybridization, P2. Your electron pair is what here? Lone pair. Hybridization will be 3. So, what will be the hybridization for you are getting? sp3 hybridization. So, nitrogen is getting sp3 hybridization. Next, after that, after formation of the bondings, what is the change they are occurring in this case? Now, if you observe what happened, nitrogen, I am drawing this structure like this, hydrogen, hydrogen, hydrogen. Otherwise, you keep this nitrogen also here on. Right? Next, a day2 bond it is. It's a day2 bond, BF3. Now, in this case, what happened? Same thing is happening. You just select how many bond electron pairs are there. Around nitrogen, how many electron pairs are there, beta? Around nitrogen, how many electron pairs are there? Around nitrogen, 4 electron pairs are there? 4. If you have 4 electron pairs, what will be the hybridization? When you have 4 electron pairs, so here electron pairs are how many here? 4. What hybridization you got here?
sp3.
sp3 hybridization. And here also boron is having, see, 1, it is also belongs to boron also. When you keep a bond between nitrogen and boron, it belongs to both atoms here. So how many again? Here also? sp.
Yes, sp3.
Understood here. So what your answer here? In this case, boron hybridization is changing from sp2 to sp3, but nitrogen hybridization from sp3 to sp3 only. No change for nitrogen, but there is a change for what? Boron to boron. There is a change for what? Boron. Here, one more thing I explained. When you remember that valence electron pair theory, double bond also taken as a 1 electron pair only. Triple bond also you can take 1 electron pair only. Single bond also you can take 1 electron pair only. Lone pair also you can take 1 electron pair only. This is you have to remember compulsory. This is compulsory one. I will explain later this one, why it is. Okay. Understood one? This question, everyone? Any doubts you are having? Reply immediately. We don't have.
No, sir.
Right.
No, sir.
Have you taken this one? Take snapshot of this one. All of you. Take snapshot of this one. Because it is in this way, if you remember what happened, it will be easy for you. Next question, if you observe what happened, draw the diagrams showing the formation of double bond and triple bond between C2H4 and C2H2 molecules. So already we discussed this one today only. What is the total number of sigma pi bonds in the molecule? C2H2, C2H4, just today only we discussed, isn't it? In this case, C2H2, there will be what? There will be what? 3 sigma bonds, okay, and 2 pi bonds here. Next, in the case of C2H4, we have what? 5 sigma bonds and here 1 pi bond here. 1 pi bond, right? Completed it is. In this, already we discussed this one. Now, if you observe this one, consider x-axis as an internuclear axis. The following will not form sigma bond y. 1s, 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 2px, 2py, 2py, 1s, 2s here. So see one thing actually. So see, to overlapping what happened, they should have similar energy, no? They should have similar energy, no? So will not form. They're asking what? They will not form what actually? Sigma bond. Which will not form sigma bond. 1s overlapping. You observe what happened? Hydrogen. I'm drawing over here better. Here I'm drawing here. Hydrogen, hydrogen. Here s orbital, here s orbital. So sigma bonding is taking place. This is happening, correct only it is. 1s and 2p are x orbital. It is also possible if you observe HF. In hydrogen again, s orbital, 1s orbital only. In fluorine, which orbital involved? 2p orbital is involving. So definitely we'll get here. It is also possible. 2p by 2py is possible. In oxygen, pi orbital is forming. Sigma and pi bar. This pi orbital is forming with one p orbital and p orbital. And this 1s and 2s is not possible. Why? Because 1s and 2s are not having similar energy. They are different energies. In according to hybridization, what I said, the orbitals must be in similar energy, same environment they should have. So this is not at all possible. It is impossible, right? I'll move to mod next. What happened? 4.30 I will explain, okay, later once we complete this one. What do you understand by bond pair, lone pair of electrons? Illustrate one example. Just now I told what is bond pair and lone pair. You take water and show me what are lone pairs we're having. Everything you can do this one. Distinguish between sigma and pi bond. So this one I will explain here. Distinguish what sigma and pi bond. Sigma bond is actually how it takes place here. Sigma bond takes place by axial overlapping. Sigma, I'm writing over here. Sigma and pi bond. Sigma overlaps for axial overlapping. Where pi bond overlaps how? Sideways overlapping. Correct?
Sideways.
Sideways overlapping. And sigma bond can exist independently. Independently it can exist. But pi bond, it needs sigma bond. Without sigma bond, there is no pi bond. I can write here, without sigma bond, there is no what happened? Without sigma, there is no pi bond. So if you want to write pi bond, how to write pi bond here? You can make over sigma bond, pi bond like this. Now sigma bond is strong bond because axial overlap, head-on overlapping it is. Axial or what? Head-on overlapping. Sideways is very weak. This is very weak bond it is. So this is the way you can write the many differences between the sigma bond and pi bond actually. Now explain the formation of hydrogen molecule based on valency bond theory. So for this one, what happened? We'll see hydrogen and hydrogen. In hydrogen, s orbital. In hydrogen, s orbital. So what type of overlapping is taking place? Sigma ss overlapping is taking place. Correct? For example, in H and F. S orbital, p orbital. In fluorine, p orbital involved. Why? Because configuration of the fluorine will be 2s2, 2p5. That means 2p5 can I write like this? 2p5, 1, 2 like this. This is the orbital which we can call pz orbital. So sp overlapping. Now pp overlapping will take oxygen. Oxygen, if you observe what happened, pp overlapping we can take. This pi bond. pp overlapping. Configuration of oxygen will be 2s2, 2p4. No, 2p4 means I can write like this. 2p4, 1, 2, 3, 4. Like this is 2p4. What actually? Oxygen. Now this will form sigma bond. This will form pi bond. So this is a pi bond, something like this. Okay. Now let me see this 4.30 now. So this we will finish this one within 5 minutes like this. So 4.30 we'll discuss now. First one is what? CS3, CS3. Let me see this one better. CS3, CS3 now. First one is they given. CS3 they given. CH3. CH3. I'm writing this one. In this way I'm writing. CH3, CH3 we can write like this. Can you place pi bond over here? Is it possible? Impossible. You can't place a pi bond. Now, if you have no pi bonds, what will be the hybridization of this carbon beta? Do you have any pi bonds here on this carbon? Or on this carbon, do you have any pi bonds?
No, sir.
No. Therefore, hybridization will be sp3 for this one. For this one also will be sp3. Now let me move to what next structure will be what here? CS3, CS double bond CH2. Now right, I'm writing next one. CS3 like this. Next CH double bond CH2. CH double bond CH2. Right? This one is the, in anywhere if you observe, carbon will have only 4 bonds. Anywhere you observe, carbon will have 4 bonds. Now tell me, this carbon, does it have any pi bonds? Tell me.
No, sir.
Therefore, hybridization will be sp3. Now, this carbon is having any pi bond?
1 pi bond, sir.
Therefore, it will be sp3. If it is having what? Here also this carbon, this pi bond belongs to both carbons, correct or not? This pi bond belongs to both carbons, so it is also what? sp3. So, I am writing here beta, no pi bonds. No pi bonds. There are no pi bonds here. Hybridization will be sp3. You have a double bond is there. Double bond is there. sp2. Okay. You can show like this also. Both are what? Same one. You have two pi bonds are there like this. Sp. Now one more thing I am writing. This one beta. This is also what? Sp only, because how many pi bonds are having? Two pi bonds are having. Here what? Two pi bonds are having. Here how many? One pi bond you are having. Here what? Zero pi bonds are having. Understood? So this is pi bond. This is pi bond. This is how many pi bonds? Pi and pi like this. This concept, if you understand, definitely you can do n number of problems. We'll take one more thing also. One more molecule we'll see here. C, CS3, CH2, OH. C, CS3, CH2, OH. I will just draw the structure and you have to identify this. CS3 completed, CH2 completed, OH. Now for oxygen, no need to write any hybridization, write down for carbon. Okay. Now you can do this one, I think. There are no pi bonds, correct or not? Do you have any pi bonds here?
No, sir.
Now
No,
next
sir.
one, D, CS3CHO. Next one will be CS3CHO. Now this carbon is not having any pi bonds, but this carbon is having a pi bond. One pi bond is there. One pi bond. Correct? Here zero pi bonds are there. Now you have to identify the hybridization. Next one will be the CS3COOH they given. Same thing. Here zero pi bonds. Here one pi bond is. This is the pi bond. Now you can give the answer for this one. Okay. This is the fourth one, fifth one. You can make answers for this one. The first one, second one I have completed. Okay. Now in your notebook, what happened? Draw these structures and write the hybridization. Take a snapshot of this one. Otherwise, I will record this. Already it is being recorded, so you can watch from that one also. So this is about what actually questions from what? Valency shell, valency bond theory, and what happened? Hybridizations here. So tomorrow I will start what? Molecular orbital theory. We'll discuss that one. Here some more questions will be there, but anyhow, this hybridization in case of PCl5, there are axial bonds longer as compared to equatorial because of trigonal bipyramidal. Okay. So remaining we'll discuss tomorrow that molecular orbital theory here. Right. Now we have any in-text questions? Let me see this one. Right. No, I will take attendance. Only 46 students. Day by day, what happened? Okay, no problem. We will see what tomorrow onwards what happened. Whoever not join, what happened? I will delete permanently. I will delete them. Permanently, I will delete them. So no use. No, tomorrow onwards what happened? Whoever absent without any permission, tomorrow onwards anybody absent, I will remove from the Google Classroom. So you can't join in classroom. Even you can't write exam also. You know the value of the exam. I think if you pass in exam in PT1, PT2, PT3 only, you will be promoted to what? 12th class. Remember that one. So you send this message, pass this message to your friends. Whoever absent today, pass them. Understood? If they don't attend tomorrow onwards, what happen? I am deleting permanently from Google Classroom. So you can't write any exam because exams will be conducted over Google Classroom. Next month, you may have PT2, PT2 3 exam, PT2 exam will be there, half yearly exam, PT2 will be there. So remember this one.
Sir, in January.
In December, we will. In December. Now I am taking the attendance now. Abhishek Y. Akruti.
Present, sir.
Present, sir.
Anshu Yadav. Anushka.
Present, sir.
Ashif. Adar, Atul Rawat, Ayush, Bharati,
Present, sir.
Chaitanya,
Present, sir.
Venusri,
Present, sir.
Jnaneshwari,
Present, sir.
Gule Ritesh, Gulabi,
Present, sir.
Krunal,
Present, sir. Present, sir.
Omkar DM, Omkar PC,
Present, present, sir.
Present, sir.
Shah,
Present, sir.
Raghav,
Present, sir.
Present, sir.
Raj,
Present,
Ravina,
sir.
Riya,
Present, sir. Sir.
Sahil, Samruddhi,
Present, sir.
Na, Sardak,
Present, sir.
Shashidhar, Sri,
Present, sir.
Present, sir.
Sneha, Sonali,
Present, sir.
Sumit, Suraj, Swastika, Tejas,
Present, sir.
Vaishnavi, Jay,
Present, sir.
Vedant, Vishal, Yash.
Present, sir.
These are the presentees. And pass the message that tomorrow, if anybody absent without any permission, you will be permanently deleted tomorrow. Only last chance tomorrow. If they don't join, what happened? I will permanently delete, isn't it? I will show that one also. Screen also I will show tomorrow. Permanently I will delete them. And if you have any doubts, you stay with me.